Hey everyone, welcome back to Chemistry CC for you. Today we are going to do a video as promised on the Pondicherry University MSc Chemistry entrance questions. I have taken all these questions from the 2018 question papers. So comparatively, Pondicherry University exam is not very difficult. It is good and it is intermediate level of examination. You have some very simple questions and a very few difficult questions, but you can do well if you have a moderate amount of preparation in this examination. So what we are going to do is we are going to discuss a few questions, and also you can watch all the previous videos on Pondicherry University entrance examinations in the description box below. Also towards the end of this video, I'll post, you can find the link there as well. Let's begin. So the first question here is a very common question for all the entrance examinations. For that matter, in any exam, this question can come because it is from aromaticity. And in aromaticity, you can describe a compound as aromatic, anti-aromatic, etc. based on Huckel's rule. And Huckel's rule states that a compound can be aromatic if it is a planar, cyclic, conjugated system with 4n plus 2 pi electrons, where n can have the values ranging from 0, 1, 2, 3, etc. And it is anti-aromatic if it is a planar cyclic conjugated system with 4 and pi electrons. But the difference is that here the n has values starting from 1, 2, 3, etc. Now here the question is to find something which is not aromatic. So we'll take a look at each of this system. This first system, this is planar, since all the carbons are sp2 hybridized. This is planar, and also this is having a conjugated system, and the negative charge contributes 2 electrons. So the total is 2 plus 2 plus 2, which is 6 electrons, and 6 electrons corresponds to 4n plus 2 pi electron, where the value of n is equal to 1. So therefore this is an aromatic system. Now let's take a look at the second system. The second system is again a planar system, and it is having 2 pi electrons. It is a planar and conjugated system. Also it is cyclic, and we have 2 pi electrons. 2 pi electrons correspond to 4n plus 2 pi electrons, where n is equal to 0. So n is equal to 0, and we can conclude that this is also an aromatic system. This third system is very well aware for all of you, which is a pyridine system. Pyridine is already an aromatic compound. The lone pair of the nitrogen is not contributing into the conjugation. Therefore, this is having only 6 pi electron, again corresponding to 4n plus 2 pi electrons, where n is equal to 1. But this final system here is, this is planar and this is cyclic. Also, it has conjugated pi electrons, but the difference is that it has only 4 pi electrons. This plus sign does not, or the plus charge does not contribute any electrons. So this is a 4 pi electron system, making it anti-aromatic. So the answer we are looking for is the fourth option, option D. Again, I want to mention a special kind system where you have 4 pi electrons. So if you have this kind of a system, what you expect is this is a anti-aromatic system because you find it as 4n pi electron. But this is a non-aromatic system. It is not aromatic. Please take a look at the word. It is non-aromatic system. So non-aromatic system mostly lacks any one of this condition. Either it will not be planar, or it will not be cyclic, or the system might not have conjugated pi bonds. So here this particular carbon is sp3 hybridized, making it non-planar. So this particular system is a non-aromatic system. Be very careful about classifying the aromatic, anti-aromatic and non-aromatic systems. Now we'll go to the second question. This question is from the part of bioinorganic chemistry, and in bioinorganic chemistry I have already mentioned the trick to study the bioinorganic chemistry. What you have to do is that you have to find the metal atom which is contributing to this particular complex and the major function of that biomolecule. Here I am going to mention the function of each of these biomolecules. You can note it down for your future reference. So transferrin glycoproteins are usually used for the transport of iron. So the function of transferrin is the transport of iron. From the name itself, it is very clear. Transfer. Trans is a transport. So ferrin actually indicates iron. So transferrin used for the transport of iron. Second is ferritin. Ferritin is a storage protein and it stores iron. So that is also not the one we are looking for. Here what we are looking for is a biomolecule which is capable of helping in electron transfer, that too in plants and bacteria. So our third biomolecule is myoglobin, and we are all very aware of myoglobin and hemoglobin. Myoglobin is an iron and oxygen binding protein, and it is used for the storage of molecular oxygen, and definitely not a electron transfer biomolecule. So the answer we are looking for is option D, ferridoxin. We'll take a look at what ferridoxin is. Ferridoxins are very small proteins and they are made up of iron and sulfur clusters. So iron and sulfur atoms will organize themselves into clusters, and these act as capacitors. So biological capacitors. What is the function of a capacitor? A capacitor can either accept or discharge electrons. Accept or discharge electrons. When it happens in a biological system, we call them as biological capacitors. And since there is a transfer of electron, there should be some oxidation and reduction going on in this whole procedure. So the oxidation stage change is from +2 to +3 for the iron atom. These are the points that you have to remember from the part of ferridoxin. Hope you have written down these points. Let's go to the third question. This is a very important type of problem. Again, a very common question for all entrances. This is for the completion of a nuclear reaction. So the idea or the basic trick is to find the sum of both atomic number and mass number in LHS and RHS and make them equal. For example, let's take a look at this question. Here in LHS, the sum of atomic number is 15. 13 plus 2, it is 15 in the LHS. So if we consider the missing species to be X, to make the LHS equal to the RHS, what do we need? We need the atomic number of the missing species to be 1. Only then the LHS will be equal to RHS. So we have solved half the problem here. Next, what we have to do, we need to find the sum of mass number in the LHS. So in LHS, we have the mass number as 27 plus 4, 31. And in RHS, we have only 30. So the mass of the missing species should be 1. And there goes, the answer is solved. It's option 4, this hydrogen. So we have the mass number and atomic number as 1, and that is the missing species in the nuclear reaction. So the idea is to find the sum of both atomic number and mass number and just make them equal in both LHS as well as RHS. Now let's go to the fourth question. This is again a very important question from the part of chemical kinetics. I have previously solved many questions from this part. Again, let's take a look at this. So when you are having a statement question like this, so in this question they have given that the given equation changes or the rate of the given reaction changes. When only chlorine concentration is changed, it is doubled, and when both concentration are doubled, it changes by a factor of 8. So what you are going to do is to consider, we'll consider each of the statements given here. So the rate can be written as rate constant into the concentration of NO raised to X. So this X is the order of this reaction with respect to the concentration of NO, and Y is the order of this reaction with respect to the concentration of chlorine, with respect to the concentration of chlorine. So now we'll take a look at it, each of the sentences given here. First the sentence given here is the concentration of chlorine is doubled, the rate is increased by 2. So what we are going to do is we'll change the equation. So we'll write the new rate as K into NO raised to X and 2Cl raised to Y. So what is this 2Cl? Actually, we are doubling the concentration of chlorine. And in the question, it is already given that the rate then becomes 2 times what it previously existed. So we get 2R is equal to K into NO raised to X, concentration of NO raised to X, and also concentration 2 into concentration of chlorine raised to Y. Now let's take a look at, let's take some scenarios. Suppose here if the value of Y is equal to 2, the whole rate should become 4R, or the rate should be increased by a factor of 4. But here that doesn't happen. Here what happens is when we are doubling the concentration of chlorine, it directly increases by a factor of 2, which indicates that this reaction rate is first order with respect to the concentration of chlorine. Thereby, we can write that Y is equal to 1, implies it is first order with respect to chlorine. Now let's go to the second part given. On doubling both the concentration, it changes 8 times or changes by a factor of 8. Again, we'll do the same set of procedure, but here the difference is we'll always already we know that y is equal to 1. Now we need to solve for x only, and the new rate should be 8 times the previous rate. So for that to happen, x should be equal to 2. See, suppose here if we have x equal to 1, then the whole rate should be changed only 4 times the previous rate. Why? Let's take a look at this. If it is x, suppose if x equal to 1, what would be our value? It would be K into concentration of NO into concentration of 2 times the concentration of Cl. Let's take only Cl, then 2 times the concentration of Cl into 2. So what should be the value? It should be only 4R, but here we have 8R, which suggests that it is second order with respect to the concentration of NO. Therefore, the total order will be equal to the sum of the powers, which is x plus y equal to 3. So the answer is last option, option 3, and therefore we solved it. So in kinetics, what you have to do is whatever statements are given for you, try to put it in some equation, rate equation, and then try to solve them. This is the basic procedure, and it would work without a mistake. If you do this procedure, it is going to work for you in the examination hall. Now I'll go to the next question. This is a very straightforward question. What is the IUPAC name of the compound? So the two things, two confusions that occur is which is if this is pyrrole or if this is pyridine. That would be the question. So anyway, this is a 5-membered compound, so it is pyrrole. And next, the numbering starts from here. So 1, 2, and 3. So this is 3-amino pyrrole. The answer is option D, 3-amino pyrrole. It cannot be pyridine because pyridine is a 6-membered ring, and pyridine is a 6-membered ring with nitrogen in it. So this is pyrrole, and since the substitution takes place at the third position, we will write it as 3-amino pyrrole. Now we have to take a look at the 18 electron rule. So according to 18 electron rule, a system should have the total number of electrons as a factor of 18. So it can be 18, 36 and so on. Then we can say that it obeys the 18 electron rule. We will take a look at the contribution of each of the atoms, how many electrons each of these atoms contribute. So manganese has an electronic configuration of D5s2, which sums up to a total of 7 electrons. Similarly, iron has a configuration of D6s2, which makes up 8 electrons, and each of the carbon monoxide gives you 2 electrons. Now we will take a look at each of these systems. First, in MnCO5, Mn contributes 7 electrons, and each of the carbon monoxide contributes 2. So we have 7 plus 5 into 2, making up a total of 17 electrons. Now the answer here is already done because it is not a factor of 18, making it the answer we want. But I want to discuss a few more points. Therefore, I'll be taking a look at the other systems as well. In Mn2CO10, what happens? We have 2 into 7, which makes up 14, plus 10 into 2, which makes up uh, 20. So we have 34 electrons already. So where does this 2 come from? That is an important question. So there is a metal-metal bond in manganese. So what happens in the structure of manganese is you have manganese, each of the manganese will be having 5 carbon monoxide on them. So we have 5 CO will be there. I'm not drawing everything, but you just understand that each of the manganese will be having 5 of the carbon monoxide. But these two should be linked to each other. None of the carbon monoxides are forming any bridge. So this will be connected by a metal-metal bond which contribute 2 electrons, thereby making up this system to a total of 36 electrons. So this is obeying 18 electron rule. Next, let's take a look at FeCO4 2 minus. So in FeCO4 2 minus, Fe contributes 8 electrons, which is already known to us, and 4 of the carbon monoxide contributes 2 electrons each, making it up to 8. So 8 plus 8, 16, and another 2 electrons are there. So where does this 2 electron come from? This comes from the negative charge. So you have a -2 charge here, which we should add to the total number of electrons, which makes it up to 18. Again, this obeys 18 electron rule. And FeCO5 is pretty much straightforward like MnCO5. It is 8 plus 5 into 2, which makes up 18. Further, if you have in another system which has a positive charge, what you have to do is you have to minus one electron from the total number of electrons to arrive at the to check for the 18 electron rule, whether it is obeyed or not. So this is how you proceed in the carbonyl compounds part. And I strongly suggest you to go through the structures of all these carbonyl compounds like CO2, CO8, and of iron, everything, because it is very important that from the structural information you might be asked to answer some question. So all of you, despite of what entrance you are going to write, please go through that portion. Now, next question. This is a very primitive question. The skew conformation is an intermediate arrangement between. So, not enantiomers and diastereomers. They are totally different concepts. D and N conformers and cis and trans isomers. All these are different conformers. The eclipsed and staggered forms. The intermediate of the eclipsed and staggered form is actually the skew conformation. And where does this actually come? So, these systems are usually studied when we have some system like butane. So when in butane or something, if you have two CH3, if you have a system with two CH3, they are in the opposite sides. Okay, I'll draw it once again. So one of the CH3 is here and the one is like this. So if you have two methyl groups, this is a staggered conformation. And what would be an eclipse conformation? An eclipse conformation will be something like this. An eclipse conformation will have one Me like this, and the other one will be very close to it, making the bulkier group very close to each other, and this is an eclipse conformation. And thirdly, you have something intermediate of both of this, which is we will have Me like this and another Me. It was not very close, but it will be like this. Okay, so these are the things that you have to take into account when you are doing the eclipsed and staggered forms. And skew conformation come in between both this, so they are not very close, but they are not far and stable like staggered conformations. That's it. Now we'll go to the next question. Predict the major product in the following reaction. This is also a very simple concept. Here you have to see whether this is styrene. What is given here? This compound is styrene, and you have HBr as well as peroxide. That is the most important catch of this equation. Peroxide is present. So two rules that you need to know is Markovnikov's addition, where an unsymmetrical reagent adds to an unsymmetrical alkene. The negative part go to the carbon with lesser number of hydrogen. So if there was and second rule is anti-Markovnikov's addition, where in the presence of peroxide the negative part goes to carbon atom with more number of hydrogen atoms. So what happens here? Here we have peroxide, and in this the more number of hydrogen is at this position and least number of hydrogen is at this position. Since peroxide is present, it should go to the carbon-carbon double bond with more number of hydrogen atoms. So option 1 would be the correct answer. Hydrogen will be going here and Br would be going here. Suppose we did not have a peroxide in our equation, then what would happen? If we do not have a peroxide, this would be our answer, because it will go to a carbon atom with least number of hydrogen or a more substituted carbon. If it has lesser number of hydrogen, it directly means that it is highly substituted. So that's the point that you have to keep in mind. If you have peroxide, you have to follow the anti-Markovnikov's addition, and if you do not have peroxide, you will follow the normal Markovnikov's addition. That's it. Now we'll go to the next question. Pick the more acidic compound from the lot. All of these are benzoic acid and its derivatives. So a strong electron withdrawing group increases the acidity of a benzoic acid. So here nitro group is the electron withdrawing group, and it stabilizes the carbanion obtained by the deprotonation of nitrobenzoic acid. Here our answer is option C, nitrobenzoic acid. So to understand acidity and basicity concept, you need to talk about the conjugate base of the acid. So what is conjugate base? Conjugate base means after losing the H plus, what is formed? So after losing H plus, what will be formed here? It will be forming a COO minus. and this negative charge, if it is stabilized, in such cases, uh, larger the stability of the conjugate base, more acidic the compound will be. So being an electron withdrawing group, nitro group can stabilize the conjugate base formed here, thereby making p-nitrobenzoic acid more acidic than the other compounds given here. Now, another point I want to add here is that if you have p-nitrobenzoic acid and or nitrobenzoic acid, which one should you choose? So, in such cases, you have to choose the nitro group at the ortho position, because at ortho position it has higher inductive effect compared to the nitro group on para position, and therefore it can make the H plus liberation as well as the stabilization of the conjugate base more easier. Therefore, ortho-nitrobenzoic acid is more acidic compared to para-nitrobenzoic acid. This is a probable question this year, because since it is asked before regarding the comparison of nitrobenzoic acid, this year you can expect a question wherein comparison within the nitrobenzoic acid is asked. So there should be, the answer should be ortho-nitrobenzoic acid is more acidic than para-benzoic acid, which is more more acidic than M-nitrobenzoic acid. Now to the next question. Which one of the following is not a primary standard substance to be used in titrimetric analysis? This is the basics of inorganic chemistry. What is a primary standard substance? A primary standard substance, we can make it into a standard solution by mere weighing it out. So we do not need to standardize it using a primary standard. We can make a standard solution out of it directly. So ferrous ammonium sulfate, we know all have worked with Mohs salt. So ferrous ammonium sulfate is a primary standard. Potassium dichromate again is a very common primary standard. Oxalic acid again is a primary standard. But potassium permanganate is not a primary standard. To standardize potassium permanganate, we usually use one of the above primary standards, and then we'll make it standardized. So potassium permanganate is a secondary standard substance. A secondary standard substance can always is standardized using a primary standard. Primary standard substances can be made into a standard solution directly. So I hope you are all aware of the concept of standard solutions and all these things. Since it is very simple, I'm not going to detail of those questions. Next, this is the last question today that we are going to discuss. In cubic closed packing structure of a metallic crystal, the coordination number is 12. I have already discussed all the important topics of this, all the important concept of solid state chemistry in the previous video. I'll attach the link of that video in the description box below. Also regarding chemical kinetics, I'll be giving the link in the description box below. I have also discussed a few points about the inductive effect and other organic chemistry topics. The lectures of the organic chemistry also will be available. You can check out the description box for any other related videos about the questions that we have discussed today. So that's all for today. What I have, since I have already introduced whatever the videos that are going to come in the next week, you can expect them very soon. And also we are going to make some changes in the channel, making it more helpful for you people. So for that, keep watching our channel. Please like this video, share it with all your friends. And if you have not subscribed to the channel yet, please subscribe the channel and hit the bell icon for the notifications. Thank you so much. Have a good day. Please study really well, work really hard. You can all crack the examination. It's not that very hard. Thank you.